Hey, super wow cool gang! Welcome to another episode where we explore fantastic facts of our universe. Today we'll be looking at neutron stars and sharing some very cool things about the densest objects we know about. Neutron stars are heavier than our sun but as small as a city. They have some crazy conditions that we can't study directly on Earth. Here are mind-blowing facts about neutron stars that show sometimes they are stranger than science fiction. Neutron stars start their lives with a bang. When a star that is 8 times larger than the Sun ends its life, it does not go gentle into that good night. Shifting pressure in its core causes it to collapse and trigger a supernova, one of the largest explosions in the universe. The initial flash of light, which can outshine the star's host galaxy, may last only seconds. But the resulting debris that is flung into space can be studied for millennia. When a star bigger and more massive than our Sun runs out of fuel at the end of its life, its core collapses while the outer layers are blown off in a supernova explosion. What is left behind depends on the mass of the original star. If it's roughly 7 to 19 times the mass of our Sun, we are left with a neutron star. If it started with more than 20 times the mass of our Sun, it becomes a black hole. Neutron stars contain the densest material that we can directly observe. The enormous density of a neutron star means a teaspoon of neutron star material would weigh 10 million tons. Neutron stars squeeze up to 2 solar masses into a city-size volume, giving rise to the highest stable densities known anywhere. The nature of matter under these conditions is a decades-old unsolved problem. While neutron stars' dark cousins, black holes, might get all the attention, neutron stars are actually the densest material that we can directly observe. Black holes are hidden by their event horizon, so we can't see what's going on inside. However, neutron stars don't have such shielding. To get an idea of how dense they are, 1 sugar cube of neutron star material would weigh about 1 billion tons on Earth. It's about as much as a mountain. That is what happens when you cram a star with up to twice the mass of our Sun into a sphere the diameter of a city. Neutron stars can spin as fast as blender blades. A mottled blue and black ball, representing a neutron star, spins about once per second. There are light blue ovals on opposite sides of the neutron star representing hot spots on its surface that are offset from the spin axis. From each oval is a beam of light extending from the oval out of the frame. As the star spins, the hot spots and beams come in and out of our view, making it look like the star is pulsing. Neutron stars are directly observable, usually as pulsars, the lighthouses of the cosmos. Some neutron stars, called pulsars, emit streams of light that we see as flashes because the beams of light sweep in and out of our vision as the star rotates. The fastest known pulsar spins 43,000 times every minute. That's twice as fast as the typical household blender. Over weeks, months, or longer, pulsars pulse with more accuracy than an atomic clock, which excites astronomers about the possible applications of measuring the timing of these pulses. Neutron stars are the strongest known magnets. Like many objects in space, including Earth, neutron stars have a magnetic field. While all known neutron stars have magnetic fields billions and trillions of times stronger than Earth's, a type of neutron star known as a magnetar can have a magnetic field another 1,000 times stronger. Neutron stars' pulses were originally thought to be possible alien signals. The discovery of pulsars began with a mystery in 1967, when astronomers picked up very regular radio flashes but couldn't figure out what was causing them. The early researchers toyed briefly with the idea that it could be a signal from an alien civilization. Of course, now scientists understand that pulsars are spinning neutron stars, sending out light across a broad range of wavelengths that we detect as very regular pulses, but the first detections threw observers for a loop. There may be aliens out there somewhere in space, but we haven't found them yet. Those are just a few of the things we know about neutron stars. If you enjoyed this episode, then don't forget to hit the like and subscribe buttons for more super, wow, and cool facts. That's all for now. See you on the next video.